So pH is the measure of the acidity of a solution, and what it's measuring is the concentration of hydrogen ion in moles per liter. The way it's measured, we take the negative logarithm of the concentration of hydrogen ion in mole per liter. And that gives us a dimensionless quantity. Typically it's between 0 and 14. The closer you are to 0, the more acidic the solution is. If you actually wind up with a negative pH, that means it's quite a concentrated solution. So we've got a pH scale here, and the pH of pure water is 7, and that's at 25 degrees Celsius. Now, as we go from 7 down to 0, the level of acidity, which means the concentration of hydrogen ion, is increasing, and you can see that as we have it increasing down here, 10 to the minus 6, 10 to the minus 5, and so on, right down to 1. Okay, so if at 1 mole per liter of hydrogen ion, the pH is 0. And anything greater than that, and you actually get a negative pH, which just means it's more concentrated. Now, going the other way, okay, we go above 7, so from 7 to 14, as we're increasing the pH here, we're increasing the basicity, or the basicity rather, of the solution is increasing. So in other words, the concentration of hydroxide ion here is increasing, which means the concentration of hydrogen ion is decreasing, as you can see, 10 to the minus 8, 10 to the minus 9, 10 to the minus 10, and so on. Right? So that's our pH scale. Right, we saw how to determine the pH. If we're given the pH, we can determine the concentration of the hydrogen ion just by taking 10 and raising it to the power negative pH, whatever the pH happens to be, right? These are inverse operations, right? Exponentiation and taking a log. So, and when you do take the concentration, because it's based on the pH, the units are mole per liter. Let's look at the pH, some pH calculations. So here's one. What's the pH of a solution? And the hydrogen ion concentration is 1.0 times 10 to the negative 11 mole per liter. Well, what we do, we just take the pH, put that in the logarithmic function, which you have on your calculator. So just hit the minus sign, log, whatever the pH, whatever the molarity happens to be. In this case, it's 10 to the minus 11. And you'll see the pH here is 11. And if you go back and look at our scale, you can see this is basic, right? Which means there's more hydroxide ion than there is hydrogen ion. We look at the second one. What's the pH of a solution where the hydrogen ion concentration is 5.47 times 10 to the minus 8 moles per liter? Well, same thing. It's going to be the negative logarithm of the concentration, and you wind up with 7.6. So it's just slightly basic, right? It's just a little bit over 7. So let's look at calculating hydrogen ion concentration, and given that, also the hydroxide ion concentration, because they both exist in water, whether the solution is acidic or whether it's basic. Now, for this, we have to remember that the product of the concentration of hydrogen ion and hydroxide ion is always 1 times 10 to the negative 14. And we know when the pH is 7, these happen to be equal. But they're not equal if the solution is acidic or basic. So let's look at this first one. The pH of a solution is 5.4. Determine the hydrogen ion concentration in mole per liter, and determine the hydroxide ion in mole per liter. Now, we know it's going to be acidic, because this is acidic, because this is less than 7, which means the hydrogen ion concentration is going to be greater than the hydroxide ion concentration. So let's take a look at that solution. So first we'll start with calculating the hydrogen ion concentration, right? It's 10 to the negative pH, so that's 10 to the negative 5.4. And the 3 decimal places in the coefficient for scientific notation, it's 3.981 times 10 to the negative 6 mole per liter. Okay? Now, to determine the hydroxide ion concentration, we know the product of the two is 10 to the negative 14. If you rearrange it, right, the hydroxide ion concentration is 10 to the negative 14 divided by the hydrogen ion concentration. So we'll just plug that in, 10 to the negative 14 over what we calculated here for the hydrogen ion concentration, 3.981 times 10 to the minus 6 mole per liter. And remember, this is mole per liter squared, so you're going to get the units canceling, and you wind up with mole per liter in the numerator, and our value is 2.512 times 10 to the minus 9. Now, I've rounded this a little bit, but if you take the product of these two, you'll get very close to 1 times 10 to the minus 14.